Good evening, everyone. Welcome to this Matlab Masterclass series. I warmly welcome you to the session. Thanks for coming and thank you for your time. Like today's topic is image processing using Matlab. So before we go into the topic, I would also like to thank the Andhra Pradesh State Skill Development Corporation for their support for this program. I would also like to thank you. So I will welcome the first early comers like Chaitanya. Good evening, Ramya. Good evening, DAY2. Like Abhishek. Good evening, Ram Agarwal. Good evening, Sivamurgan. Good evening, Srinivas. Good evening, Harihar Shudan. Good evening, Vishnu. Good evening, Santosh Kumar. Good evening, Bharat. Good evening, Hari Prakash. Good evening, Shubham. Good evening, Tina Chauhan. Good evening, Raju. Good evening, Chandra Maria Joseph. Good evening, Ashok. Good evening, Palas Media. Good evening, Mahesh. Good evening. So Babita, Geetanjali, Hanisha. Good evening, Ashok. Bengana. Good evening, Saram Ramesh Patel. Good evening. Okay. So thanks for coming today. So let us start the day with a quote. Let us start the day with a quote. So today quote is, have a clear defined goal with a deadline. Okay. So how many of them have the habit of writing a goal in a notebook? Okay. If you have this habit of writing a goal in the notebook, type yes in the chat box. Else type no in the chat box. Okay. I want to see how many of them have the habit of writing the goal on the notebook. Okay. Your goal should have a deadline. Okay. So if you have the habit of writing the goal on the notebook with the deadline, you just type yes in the chat box, else no in the chat box. I am waiting for your chat. If you are writing your goal on your notebook, okay, the goal should have a deadline, or else it's a dream. How many of them have the habit of, yes, I see a lot of yes here. Okay, I see a lot of yes here. So like writing a goal on a notebook, it works. Okay, all you have to do is you just write the goal as well as list down the action points you have to take to achieve the goal. Okay, you just write it down every day and see the magic after 3 months. Okay, but you have to write it down every day. You have to write down the goal every day that that is necessary. Okay, so you just write the goal with the deadline for 3 months on the notebook. Also write the action points, like what are the actions you have to take for achieving the goal, and see the magic after 3 months. Okay, it really works. So let's go into the session. So what we are going to do, what we are going to learn today. Today's topic is image processing using Matlab. Okay, so first, like I will explain you like what are the things which we are going to learn today. So today, like we are going to like how to read and store images. Okay, how to read an image on various file formats, like how to read a BMP image, how to read a JPG image or a TIFF image, and how to view the pixel values, what is pixel, so all these things, and how to write an image using IM write. So these are, and second, like we are going to cover up the types of images, what is grayscale, how a color image is stored, and what is binary image. So that will be covering up on types of images, and DICOM images, like how to read digital DICOM images, medical imaging. Okay, so that, and mathematical operations on image, how to do image addition, image subtraction, or image multiplication, or image IM complement, all those mathematical operations on an image. Okay, so and fourth, we will be covering up the channel separation. Okay, we will be reading a color image, and we'll be covering up how to split the red channel, green channel, and blue channel, because to do color image, this is essential. Like to the channel separation is essential for color image processing. So we'll be covering up how to do channel separation on a color image. And fourth, like like edge detection, like what are the various type of edge detection techniques, how can edge detection, how to do can edge detection, Sobel edge detection, okay, and pre-width edge detection. So that we'll be covering up. And how to add a noise to an image, how to add a salt and pepper noise, how to add a Gaussian noise to an image, and how to apply filters, how to apply median filters, Wiener filters, and how to do how to do filtering on a color image. Okay, so how to add noise to a color image and how to apply filter on the color image, that will be covering up. And thresholding and image segmentation, how to do a simple image segmentation based on thresholding, and how to count the number of coins in an image, okay, which is used like to count the apples or count the orange on a tree. So like with very simple code, we will be covering up a simple code of how to count the number of coins in an image. And histogram equalization, okay, contrast enhancement using histogram equalization. So these are the topics which we are going to cover up today. So if you are ready to learn, just type RTL in the chat box. I want to see the chat box. RTL, just type RTL in the chat box. Ready to learn these topics? I will go through the chat box. So for okay, I will go slow. I'll go slow. Naveen Kumar, Kalyani's Hebrace is like, I'm going fast. I'll go slow. Okay, I will go by slow. I will go through each commands. Okay, I will try to make you understand. So I will every section, like I will ask for the chat. If you are clear, just type clear in the chat box. Else repeat in the chat box, so that I go through the I will go through the chat box and I will repeat it again if needed. Okay, so type RTL in the chat box. Thank you so much. Thank you so much. Thank you Ramya. Thank you Jay Patil. Thank you Sakit Rama. Thank you so much. Okay, so I will give you a short introduction about Pantech and about me, and we could go to the topic and an announcement, and we can go to the topic. Okay, so Pantech was started in the 2004. We basically manufacture motherboards, embedded motherboards like microcontroller boards, DSP boards, and FPGA boards. We do also manufacture lab equipments for engineering colleges for electronics and electrical engineering, like renewable energy lab kit and the fuel cell trainer kit, and like solar trainer kit, and power electronics kit, and the FPGA and DSP kits, both on fixed and floating point DSPs. Okay, so if you want to know more about our products and services, just log on to our website pantechsolutions.net. Okay, our vision is to help 10 million students to learn technology in an easy way. So far, we have trained 1 lakh plus students on YouTube. So our vision is to train 10 million students to learn the technology in an easy way. Okay, so about me, my name is MK Jeevarajan. I completed my master's in the year 2004 from College of Engineering Gindi from Chennai, and my bachelor degree in Government College of Engineering Bagur in the year 2002. Basically, I'm from Applied Electronics, EC, from EC background. Like my primary expertise is on microcontrollers, DSPs, and FPGAs. I used to work on various microcontrollers and DSP processors on image processing. I have worked on a lot of image processing algorithms, like over the period. Totally, I have around 16 plus years of experience, and I am responsible for the new product development on Pantech. Like I used to work on various algorithms, like image processing, deep learning, machine learning algorithms on Matlab, on FPGAs and DSP processors. Okay. So this session is about sharing my knowledge with you. So definitely, I hope I add some value to you on this 30-day series. I try my level best to transfer my knowledge as much as possible on both mindset lessons, which I have learned so far for the past 16 years, and on the skill set. So, okay, so the coaching will be on both mindset as well as skill set. So those who attended the FPGA series, like they have gone through the 21-day mindset lessons, but this topic you will have 30 days mindset lesson. Okay, so yesterday that point we have covered up is self-education will bring you fortune, and today you have to write your goal on your notebook, okay, with a deadline. So goal without a deadline is a dream. So these are the 2 mindset lessons. So I have provided my LinkedIn link here. Like if you want to connect me on LinkedIn, just give me a connection request. I'm happy to connect and happy to help. Okay, I will also pass the LinkedIn link to the chat box now. So you could connect me on LinkedIn. I'm passing this to on the chat box. LinkedIn link in the chat box. I have put LinkedIn link in the chat box, and announcement. The attendance link will be available at 9 p.m. Okay, so no need to worry. The valid links will be valid for 2 more hours, 1 hour to 2 more hours, 2 hours of time. You could also fill the attendance even after the session. No urgency. Okay, just focus the training. So the training is the key takeaway, not the attendance. And the certificate is okay. Like you get the certificate from the Andhra Pradesh State Skill Development Corporation. Everything is okay, but focus on the session. Okay. So for internship candidates, like the attendance will be marked from the LMS portal. All you have to do is give complete and continue after watching the video. So the attendance will be marked accordingly, and the certificate will be generated once after the 30 days. Okay. So for some classes, we'll be using recorded streaming for the experience, for learning experience, or if you're not able to present it on, like if on the 30 days. So for some sessions, we'll be using recorded video streaming. Okay. So, and I would also like to give you a short disclaimer that we are not associated with Matlab. Okay. So the logo which was used and the tools which was used, the Matlab tools which was used is for is for educational purpose, and like Pantech has no association with Matlab, and all the trademarks are owned by the respective owners. Okay, Pantech has no formal MOU with them. If you want to download the trial version of Matlab, I will give you the link on the chat box now. Just give me a minute. I'll give you the link on the chat box now. You could download the trial version. Okay, on this link. Okay, it's a 30 days. So I have chatted. I have put the link on the chat box now. Okay, I will try to be slow as much as possible. Okay, on the session, like have like just go through. Let us start the session. Okay, so first we will start how to read an image and how to store the image. Okay, first I will explain you the code on the presentation, then we can open Matlab and we could do the program. Okay, so the first thing is to read the first command is the imread. Okay, imread stands for imread is a command which is used to read image, whatever the file format is. TIFF is a file format, tagged image file format, JPG is a file format, okay, JPEG file formats, and BMP is bitmap file format, and PNG is portable network graphics, and GIF is graphic interchange file format. So whatever the file format is, no need to worry. Like you just use this command, it will convert that image to a matrix. Okay, image is nothing but a matrix. Matrix will have values. Okay, matrix will have values. The values in the matrix is called pixels. Okay, pixels or pels, which contains the information about the image, and the value will be only between 8-bit, 0 to 8-bit for a grayscale image. So the value will be 0 to 255, 0 to 255. For a grayscale image. If it is a color image, you will be getting 3 matrix for red and green and blue. You will be getting 3 matrix, okay, RGB format, red, green. So the combination of red, green, and blue will give you the color. Okay, so imread is a command which is used to read the image. Imshow is a command which is used to display, okay, to display the image. And impixelinfo, like impixelinfo, is used to view the pixels. You could put the cursor on the image and you could view the pixel value. Okay, that's a command for impixelinfo. Okay, and imread is a command which is used to store the image. You could store in whatever format you want. So Matlab has few supported formats, the BMP format, JPG format. You could use the help command to know what are the formats supported by Matlab. Okay, imread is a command which is used to store the file. Okay, and below is the DICOM info is to read the DICOM images. For medical images, it is in .dcm format. Okay, DICOM stands for Digital Imaging and Communication in Imaging. Okay, communication in medicine. Okay, DICOM. So DICOM, the medical images will be in 16-bit. Okay, usually the image will be on 8-bit data, 0 to 255, whereas medical images will have 16-bit data. Okay, for the pixels. So DICOM info is used to get the information about the medical image, about the file, and DICOM read is used to read the image. Okay, read the image. Like I'm sure, like you could view the image. Okay, so I'll open Matlab. Let us practice this code. Okay. So the first thing in Matlab is you have to change the path. Okay. So I have a folder called DAY2. Okay. I have a folder called DAY2. I just copy this path. Right click and copy and open Matlab. Okay. Open Matlab. So I will close all these programs. Okay. I change the path. Right click, paste. Okay, and change the path. Else you could also type cd single quotes control V. Okay, this is used to change the path. CLC for clear screen. Okay, and clear for variable clear. Just type edit, okay, edit to open an editor window. So CLC, you always have the habit of typing CLC clear and close all, so that if any figures which was open in the previous program, like, will close. Okay, so just I'm going to read an image. I'm going to read an image cameraman.tiff. TIFF stands for tagged image file format. Okay, it is a file format. It is a way how the image is stored in the hard disk or drive. Okay, so the proper headers and footers. Okay, so imp show is the command which is used to display. Okay, and imp pixel info is for, like, to view the image. I'm saving this program as example 1 and run the program. Okay, so you could put the cursor. Like, if you check on the workspace, the value of A is that you get a matrix of 256 rows and 256 columns. Okay, and the type is uint 8, unsigned integer 8. Okay, you could double click this workspace and you could see the value of the pixels. Okay, these are all the pixel values. It will be between, the value will be between 0 to 255. Okay, so I have written a command like A equal to imread of cameraman.tiff. Show of A is used for display, and pixel info is for to view the pixel values. Okay, so you could also type who's of A here. Okay, so if I have a color image here, rose.jpg. Okay, so like this cameraman.tiff was stored in the Matlab root path. Okay, else you have to keep the images on the current working folder. Otherwise, it won't display the image. You have to give the path name as well as the file name also. Path name as well. Okay, for reading the image which was stored outside the Matlab folder. So if you check this image now, like it has 3 values. If you on the bottom, like it shows the RGB. Okay, so it has 3 pixel values. For red, you get a pixel value. For green, you get a pixel value, and for blue. Okay, it's for color image. So the combination will give you the RGB combination will give you the color. Okay, so to read image, okay, so like to write, if you want to write I am write, for example, I want to resize this image. Resize. Okay, resize is a command which is of 256 rows and 256 columns. So figure is used to open a new figure, and show is the command which is used to open. Okay. So I am right of A test.bmp. So I'm storing that as a BMP file. Okay, I'm resizing and I'm storing. So what happens? Let us keep a breakpoint. Breakpoint is used to stop the execution of the program. Okay, so when you click run, and if you type who's in the command window, like I marked this as B so that we could visualize the resized component as B. So I type who's in the command window. So the original image size is 1248. Okay, 1248 rows and like 1747 columns. Okay, into 3. Whereas like after resizing, it becomes 256 rows and 256 columns, so that you could see this is the image after resize. Okay, so I am right is used to store the image on the current folder. So if on the left hand side on the current folder, you could see the image which was created in the folder test.bmp. So this is a code to read the image. Okay, to view the pixels. Pixels are nothing but intensity. Like image will be represented in a matrix form. If it is a grayscale image, you get a single matrix. If it is a color image, you get 3 matrix. For red, you will be getting 1 matrix. Green, you will be getting 1 matrix, and blue, you will be getting 1 matrix. Okay, only combination of this pixels will give you the color. For red, you get 8-bit, and for green 8-bit, and for blue 8-bit. So totally 24-bit. The pixel representation for color image is 24-bit, whereas for grayscale it is 8-bit. Okay. So this is to read image. Show is for display. Pixel info to view the pixel value. I am resize to resize the image, and figure to display. Okay, I am write is a command to store it on various formats. If you want JPG, you put this like it will store that in JPG, test.jpg. Okay, so whatever file format you want, you could store. Okay, for DICOM images to read, always use help command. So help will give you some sample code. So I type help DICOM read in the command window. I got a sample code here. I just copy the sample code to a folder, to a file. Like I just move this indentation. Okay, so DCM is DICOM, for DCM format is the DICOM format, like digital imaging for digital imaging and communication in medicine. Okay, so if I say the program as example2. Okay, example2, keep a breakpoint. Breakpoint is used to stop the execution of the program, run the program. So if you check this variable info, you get the file name and the file modified date. Okay, all the information about the file. Okay, file name, file modified date. The file was created in 2018 December 2000, and this is the time like the file is created, and width 512, height is 512. Okay, grayscale image, and about the resolution, everything. Okay, so this is the image. Since it is in double format, like I'm sure you have to use this command because the image is 16-bit. Okay, the data is 16-bit. Okay, so DICOM info, you get the information. DICOM read is used to read the image. Info is the command which is used to display. So if this is clear, like how to read an image and how to store image, how to read a DICOM file, DICOM images. If this is clear, just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. I'll go with the majority. Okay, is that clear? Is that clear? Yes, you have to change the path. Pallavi Pansarkar, like you have to change the path. Is that clear? Prakisha Gupta, yes, I'll go slow. I will go slow. Thank you, Hema. Thank you, Aditya. Aditya is asking for repeat. Harshil, thank you. Santosh, thank you. Okay. See, I will repeat the code. I will explain the code. Like first thing, imread is a command which is used to read the image. Okay, so you should have the image on the current working folder. Okay, the cameraman.tif is not in this working folder because it is in the root path. Okay, Matlab root path. So by default it will take the image. Else you have to keep that image on the folder. Okay, imshow is the command which is used for display, and impixel info is to view the pixels. Okay, resize is a command to resize the image to various size. Image is a matrix. Okay, if you take a passport size photograph, it will be like the 256 rows and 256 columns. So like if you take a bigger image, you will get a bigger matrix. Okay, if you want to make it small, like you have to resize the image. So 256 rows and 256 columns. IMWrite is used to store the image. Okay, and to read the DICOM images, use DICOM info, DICOM read, okay, and info. DICOM info, like it will give you the information about the DCM file in the info, and DICOM read is a command which is used to read the DICOM format. So if you check on the workspace, you will get the Y value. Okay, Y is 512 rows and 512 columns, but of integer 16. Okay, and info is the command which is used for display. So let's go for the next one. Okay, so types of images. Okay, how to read a grayscale image and how to convert that to color image, how to convert that to grayscale image, and how to convert that to a binary. Okay, so imread is the command which is used to read the image here. Subplot is used for display more than one plot. Okay, subplot of 1, 3, 1. 1 stands for first row, 3 stands for 3 columns, and first 1 is the first index. Like in show of A, you will display the first image here. RGB to gray converts that to a grayscale image. It's a color image. You convert that to a grayscale image here. Subplot of 1, 3, 2. Okay, like in show of B. And binary, like IM to BW stands for binary. To convert that to a binary image. will have only zeros and ones. The pixel value of binary will be zeros and ones. For color, you will get 24-bit, three values, R, G, and B. Okay. For grayscale, only one value between 0 to 255. I'll show you that on Matlab. Okay. I create a new program. Okay. Type CLC first, clear, and close all for close all the figures which was open in the previous program. Okay. I'm going to read the image. Read rows.jpg. So this size will be big. So I'm going to resize this image of 256 rows and 256 columns. Okay. And see, I'm going to convert this as RGB to gray of B. Converting that to a grayscale image, and D, I'm going to convert that to a binary. So I'm going to use subplot. Since we have 4 images, I put 2 rows and 2 columns. This is the first image. Okay, show is a command to display the first image. So I copy this one. Okay, and this should be the second image, third image, fourth image. Okay, so this will be the B resized image. This will be the grayscale image, and this will be the binary image. To view the pixels, I type the command im pixel info. Save the program. Save the program as example3. Run the program. Okay. So if you check now, like this is the image, this is the original image, this is the resized image. Okay. Resized image of 256 rows and 256 columns, color image, and this is the grayscale image. If I keep the cursor on the image, it shows the pixel value at the bottom. Like it has only 1 pixel value at that location. It has 3 pixel values at this location, and this as having only zeros and ones. The value of the pixels will be only zeros and ones for the binary. Okay. So this is to read the image, to resize the image, to convert that to a grayscale. You cannot convert a gray back to a color. Okay. But there is a command called label to RGB, but it does not give the color. It will not give you the color, but it will convert that to RGB format. IM to BW is for binary image, to convert that to a binary image and display. Okay. So the next is how to do mathematical operations in image. Mathematical operations in image. Okay. So like image addition, image subtraction, image complement, and IM multiply. Okay. So I will go straightly to the Matlab. So I read an image. Okay. So I read an image in read of cameraman.tiff. Okay. So you have B equal to im add of A, 50. There is a command called im add. Okay. Im add of 50. Okay. And you could view this image like subplot of 1, 2, 1 of show of A. Okay. And B. So save the program as example 4. Okay. This is 2. Okay. So if I add 100, it increases the intensity. Okay. This is the value of adding 100. I add 255. 255 is the maximum value a pixel can have. Okay. So it becomes white. Okay. So this is for image addition. You just type help im add in the command window. It will give you the various other commands like which you could use for mathematical operations, like im absolute difference, im complement is there, like im divide, im multiply, and im subtract. Okay. So you could also read and you could also rise.png. These are the images which are stored in the Matlab root directory. I'm adding 2 images now. Adding 2 images. See, I'll put it on C now. Okay, I'll put it on C. This is C. This is 3. Okay, so I'll explain you the code. I read 2 images, cameraman.tiff and rise.png, and I use im addition. Okay, and like subplot of 1, 2, 3. C. Okay. It should be 3. should be 3 because we have 3 images. Here. So you have a cameraman.tiff and rise.png. Okay, this is the addition. Okay. You could use the same code for IM subtract. Okay, IM subtract. Okay. So I read this image, read rise.png, IM subtract as a command. If I want to do, I will show the IM complement. Okay, IM complement it was generally used for binary images. Close on. So convert this to IM to binary. Okay, I'm converting this to binary, and I am using complement. Save the program as example file. Complement will have only one IM complement. Okay, so this is using IM complement. Okay, so I will repeat the program again. So image addition, like image addition is like you could read the image. IM add is the command. You could also directly add the pixel value. Else, you could add 2 images. Okay, so whatever you want. IM subtract is also same thing. You could also add subtract a pixel value, or you could add 2 images. Complement is for just complementing the image. Mostly IM complement is used for binary images. It also works for grayscale image. Okay, so like if you type help IM complement in the command window, like you will get a sample code. Okay, you get a sample code here. You just choose a sample code, right click, go for evaluate selection. Okay, F9. So like this is a glass image, it's a grayscale image, and it takes a complement. Okay. If this is clear, just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. I'll go with the majority. Is that clear? For subplot, you could also make 5, but one figure will not be displayed. Okay. Abhinandan Paul, need of figure once again. Okay. Is that clear? Thank you, Ankit. Thank you, Mohan. Thank you, Ravali Ancha, and Aniket Shah. Thank you, Lakshman Kumar. Thank you. Is that clear? Just type clear in the chat box. Tritika, thank you. Saurav, thank you. Okay. Dinesh, thank you. Okay. So let us go for the next program. Okay. So color channel separation. First, I will explain you the code on the presentation, and then like we could go for the code. Okay. So like color channel separation, it is generally used for color images, like to do color image processing. IM read is a command which is used to read the image. Okay. IM split is a command which is used to split the channels. This command is available only on 2019 and above versions. Okay, if you use 2018 or below 2018 or 2017 versions of Matlab, IM split is not there. Instead of that, you have to do it in another way. I'll also explain how to do that. Okay, and like you will have 3 planes for color images. You will have 3 planes. The first plane stands for red, and for second plane stands for green, and the third plane stands for blue. Okay, after splitting the channels RGB, load the red component on the first channel and make the rest of the channel as 0. Okay, so colon comma colon means it means like it takes the all rows and all columns. If you give a value there, it will take only that particular value of the pixel. Okay, particular location of the pixel of the matrix and on the image. If you give colon comma colon, it takes all rows and all columns. Okay, so for green, you have to load the second channel and make the rest 1 and 2 as 0. And for green, like for blue, like you load third channel and make 1 and 2 as 0. Okay, I'll go for Matlab and I'll show you the code there. Okay. So CLC and clear and closer. Okay, so I'm reading an image. I'm reading this rows.jpg. Okay, I'm using RGB. I'm splitting this command equal to IM split is the command to split the channels of RGB. Okay. So this is the red component. Okay. So you could also load red equal to A first, and you could put red equal to A of 1 is R. Okay. First channel, it should be second and it should be third. Okay. Second and third is 0. Second and third is 0. So I figure of show to view that, save the program as example 6. Okay. And you run the program. So this is the red channel. Okay. This is the red channel here. Okay. So if you want to view the green and the blue channels, like, so I'm loading green equal to A. First I'm loading that. Okay, green. So colon comma colon 2, I have to make it as G. Okay. So on first and 3. So this is used for color image processing. I'll also give you one example code on how to do that on color image processing. This is 0. Okay. So this will load the green. Okay. So run the program. Get green here. Okay. Get green. For blue, like, you just go for blue. First load blue, like, okay, comma 3 equals B. It should be 3. Okay, 2 and 1. 2 and 1 as 0. Okay. Figure of show of blue. Okay. So save the program and run the program. Okay. So this is the blue. Okay. I'll explain you the code one more time. And say, actually, like, we have read image. We have read image. And IM split, like, it separates red and green and blue. Okay. It separates the red, green, and blue. If IM split is not there, if IM split, this command is not there, you could also do the same thing by R equal to, you could load this one. Okay. And G equal to, like, 2 and blue. Okay. You could both work same thing, like, it separates red, green, and blue. You are loading the red component here. Okay. Red component here. This is just to initialize the matrix. Like, red, you load in the first plane red, and the rest of the planes you make it as 0. And display I am red and for green. Okay. So if you run the program, red, green, and blue. Okay. If it is clear, just type clear in the chat box. We could go to the next program. If you want me to repeat, just type repeat in the chat box. A.I. Data Science, thank you. Clear. Hi Kumar, the order is mandatory. Yes. Surya, thank you. Surya PS, thank you. Aditya Gupta, I don't know Hindi. Ritvik Singh, thank you. Sumaradi, thank you. Anikat Shah, thank you. Himanshu, thank you. Okay, I'll go with the majority. So everyone is clear. Okay, so I'll go with the majority. Thank you so much. Okay. So coming to edge detection, I will explain you the code for edge detection on the presentation. Then we could go for the code. Okay. So IM read is used to read the image. Then RGB to grade, that to convert, because edge will work only on grayscale image. It won't work on the color image. Okay. So you have to read the image, convert that to a grayscale. Edge of canny. There are like 3 algorithms. Like, there are a lot of algorithms for edge detection. You could also write your own code for edge detection. Like, canny is a type of algorithm, like, and Sobel is a type of algorithm, and Previt is a type of algorithm. Okay. So so if you give canny on the single quotes, like you could type help edge, and you could check out on the Matlab what are the method it supports. Okay, let us go for the Matlab. If you type help edge in the command window, okay, help edge in the command window, it will tell you like what are the methods like it could support. What are the methods like Roberts and like previt. Okay, so these are all the different types of edge detection techniques. Sobel is a edge detection technique. So edge is a feature extraction technique. Like most of many applications needs edge detection for feature extraction, like for segmentation, for background, like for getting the counter of the object. Okay, so let us go for the program. So I'm going to take a grayscale image, cameraman.tiff, cameraman.tiff. Okay, cameraman.tiff. So b equal to edge of a, edge of a, and canny. Okay, canny you have to give in single quotes. So let us and c equal to like edge of a using like previt is a different type of method. Okay, and Sobel. D is based on Sobel. A comma H. Okay, so I'm going to use subplot. So totally we have 4 images, 2 comma 2 comma 1. Okay, show of A. Okay, this as second image, third image, and this is fourth image. Okay, this is B and C and D. Different types of methods by using edge for edge detection. Example, I say this example as example 7. Example 7. Okay, so I read the image, cameraman.tiff, edge is a command. If you don't know how to use this, you always use help command. Okay, always use help command to find out. There will be an example here. Okay, always use help edge. Okay, help command, like help. If you type help edge in the command window, like it tells that syntax. Okay, sorry. Previt, canny, previt, and what is the next method? Is Sobel. Is Sobel. Sorry, it's Sobel. Okay, so you could give figure, like this will open up the new figure here. I will clear the variables which was created in the previous program. Close all. Sometimes it may cause error. Like if you have not cleared the workspace, okay, it may cause error. Okay, this is the code. Okay, image. You have this canny, and this is previt, and this is Sobel. Okay, in read edge of a of canny and edge of a of previt Sobel. So these are the methods. You also have other methods, Roberts method and methods. You could use the help command. Okay. So the next is noise and filter. Okay. So we have caught up page now. The next is noise and filtering. So I'm going to read image, cameraman.tiff. Okay, cameraman.tiff. I'm going to add noise to this image. Help I am noise. You just type help I am noise in the command window. You get a syntax here. Just copy the syntax here. Okay. Salt and pepper noise. This is the noise variance. I'll show you. And like C, you could apply median fill to of A. Okay. And this is like 3x3 is a mask. I'll tell you how it works. Subplot of 1 comma 3 comma 1. Okay, and show of A. Okay, so we have read an image. In read is to read an image, apply salt and pepper noise to the image. Okay, salt and pepper noise to the image, and we have applied the median filter. I will tell you how median filter works. Example 8. This is example 8. B and C. Okay, so immediate filter to what is this noise? I variable. Okay, this should be A. Okay. So if you check here, like this is the input image, this is the noise added image, salt and pepper, like just like you put salt and pepper on the image. Okay, like salt will be white and the pepper will be black. Okay, so this is the median filtered image. You could add the noise variance here. Okay, noise variance here, and this is the filter image. I'll tell you how it works. Okay, so if you check the workspace, this is the input image which contains the pixels. Okay, and B is the noise added image. So if you check noise added image, they have added two kind of noise. One is the salt and the other is the pepper. Like the salt is white, so it is 255. So this one. Okay, the pepper is black, it is 0. Okay, they have added 0 and 255 on randomly. Randomly they have added 0 and 255 on the matrix. Okay, so that adds the noise to the image. So for and C contains the median filter. Okay, median filter image. Actually, what happens in median filter is, for example, you take this 2 cross 2. The 2 cross 2, they take the nearest pixels, nearest neighbors. Neighboring is totally 1, 2, 3, 4, 5, 6, 7, 8 neighbors are there. Okay, 3 cross 3, including that pixel, it will be 9. So totally they take the median value for the 9 pixels and they replace the pixel with the location, the pixel location. For example, if you take 1, 1, the neighboring pixels is 1, 2, 2, 1, and 2, 2. They take the median value for this 3 value and replace this value. For 3, take 5 values. The neighbor is 5. Take the pixel value and replace this value. And for 2 cross 2, the neighbors are 1, 1, 1, 2, 1, 3, 2, 1, 3, 1. These are the neighbors. Just take the median value for that and replace the value. Replace of 2 cross 2. Like that, you have to pass the window. Okay, it's 3 cross 3. Okay, this is that denotes the 3 cross 3. You could also go for 5 cross 5. I'll show you like if the pixel value, is, I'm increasing this pixel. Okay, I'm increasing this one. Okay, now like the entire image has been like noisy, but this is the filtered image. Okay, so I'm still increasing to 92. Okay, so you could also put 5 cross 5 here. 5 cross 5. It takes a 5 cross 5 mask. Okay, 5 cross 5 mask and takes a pixel value. Okay. If this program is clear, just type clear in the chat box. I will show you how it works for the color image. Okay. Uday Kiran, thank you. Ram Shankar Singh, thank you. Fatima Begum, thank you. Is that clear? Just type clear in the chat box. I'm waiting for your chat. It will take 20 seconds or to 30 seconds to reach me. I'm waiting for the chat. Sunil Kola, thank you. Shiresh Mohan P, thank you. Abhishek, thank you. Hinal Shah, thank you. Aniket Shah says it's repeat. Himanshu also says it's repeat. Okay, see, I will the same code. I will do it on the color image. Definitely, it will be clear for you. Okay, so if I put rose.png, okay, if I put rose.png, rose.jpg here, let us check whether the program will work or not. Okay, it shows error. It shows error. Okay, because it should be two-dimensional. So the median filter will not work for the color. Okay, so in that case, we have an image and we have added the image. So in that case, I comment this line, I comment this line and this line. Okay, let us check the output. So go for editor window. Okay, I keep a breakpoint. Okay. Okay, so this is the noise has been added. The noise has been added to the color image. Okay, but the median filter works only for grace, like it's a two-dimensional pattern. It won't works for the color. In that case, what we have to do is, like, we have to use the im split command, RGB. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we have to use the im split command. Okay, we equal to IM split of A. Use IM split, and like you have to use the median filter. Okay, have to use the median filter for 3 times. Okay, you pass the red here first, and for green, for blue. Okay, blue, and this is green, and this is red. Okay, you pass it for 3 times RGB. I will make this as 3x3 mask. It will also work 5x5, not a problem. It will also work 5x5. I'll make this as 3x3. Okay, and then I have to combine that to C. So C of equal to R. Okay, so combine that back again to C. I'm loading all the planes back again to color image. Okay, so if you check now, I put figure here to open a new figure. I also close the previous figures, close all, and run the program. Okay, it shows error. Okay, let us resize this image because like the size is too big. A equal to I am resize the image of A comma 256. We have to use clear. That's a problem. Okay, clear it. I think it will work. It without resize it will work. Okay. So the reason okay it should be B. Alt and buffer noise is okay. Red, green, and blue. Okay, this is B1 because it overrides B. So if you check now, like this is the image, and this is the noisy added image, and this is the filtered image back again. Previously, it didn't work. So I have used IM split command to split the channels. I have used B1 because like already we have a B here, so it overrides this B, so we are not able to view the image here. IM noise. So I have used another variable. That's all. Okay. So red I pass it to a median filter. For green I have passed to a median filter, and blue median filter again. Okay, and again combine this to an image. This is the red plane, green plane, and the blue plane. Okay, and I have used subplot to display the image. Okay, so I repeat the code. First read the color image. I have added the noise to this image. Previously it shows error because we have not used clear. So there is a variable which was stored for 256 rows and 256 columns, and it doesn't allow me to store this one. Okay. So always use CLC clear and close all. It's a best procedure to begin the code. Okay. So I am split to split to 3 planes or red, green, and blue. Okay. So apply median filter for these separate channels. Red channel you apply median filter. For green channel you apply median filter. Blue channel you apply the median filter. Combine all back again to C. Okay. Subplot of 1, 3, 1, 1, 3, 2, 1, 3, 3. So it displays now like now you got this image. Okay. Show of A. This is noisy image, and this is median filter image. If this is clear, just type clear in the chat box. I think we are running out of time. Like I will try to finish as much as possible. Is that clear? Soham, thank you. Soham Adhikari, thank you. Sorry if I have pronounced your name wrong. Like Aman Gupta, like one video, like you have a lot of videos how to install Matlab on your system on YouTube. Just go through that. Patan, thank you. Amit, thank you. Okay. Aman Gupta, you have a lot of videos on this system. Okay, a lot of videos on YouTube for everything, like even for track they have videos. Okay, okay, is that clear? Thank you so much. Thank you so much. Thank you. I'll go for the next one. Okay, thresholding and image segmentation. How to do thresholding on image segmentation and count the coins. We will finish both experiment on the same one. Okay, So it will maximum, the time is now 9:24, like we will complete within 9:30. I assure you that we will complete within 9:30. Okay, 9:30. Sorry for the still see clear. Okay, close all. So I'm going to read the image. Okay, I'm going to read the image coins.png. Okay, this is the image which was stored in the in the default folder. Figure is used to figure I'm show of A. Okay, I'll show this one, like this is example 9. Okay, example 9. So run the program. So I just display the image. We are going to count the number of coins in this image by using a simple thresholding and segmentation. Okay. Okay. So now I'm going to use a binary function to convert that to a binary, and I will show you the results. So I'm converting this to a binary. Okay. Converting this to a binary. We are going to count the number of coins in this image. Okay. We are going to count the number of coins. So after converting this binary, I have some error like on this coin. Okay, I have some error on this coin. Like so, I'm instead of going with the inbuilt command, okay, I'm using a thresholding like 100. The threshold is 100, and I'm checking the output. Okay, now it is clear, somewhat clear, when compared to the previous one, but still there is some error on the coin. Okay, so if like in order to clear this one, we could use a median filter, like a median filter 2 of B. Okay, so now I'll check this one, like I use the command figure I'm sure C to check that whether it's working. Okay, so we got some parts clear. Okay, now use the I'm going to use the bw label command. Okay, bw label of C. So this will give you the number of coins. Okay, this will give you the number of coins. So I'm going to run a simple I'm going to run write a simple for loop for I equal to 1 to num and okay, just for display I'm show of L equal to I. Okay, pass of 0.5 seconds. I'm giving delay just for visualization. Okay, so let us view this in a separate figure. So I'm getting some error. Okay, so if you check this, like this is the first coin, second coin, third coin, fourth coin, fifth coin, sixth, seventh, eighth, okay, ninth, and 10th. Okay, so totally the num, if you check the value of num, the value of num, you get the coins as 10 coins. That's so totally it is 10 coins. Okay, 10 coins. It's a simple one, but when you go for a real world scenario, the image will not be like simple like this. Like if you take a, for example, if you want to count the number of apples in a tree or number of oranges in a tree, like the segmentation itself is a complicated process, because the segmentation here is a pure black background. Okay, so like a pure black background, so the segmentation is easy when by using a simple threshold. Okay, but in real time scenario, it's not like easy for that to get the background subtraction. You have to go for a complex segmentation technique to segment the background, and then after getting the binary, then you could count the number of apples or number of orange in a tree. Okay, so which is used for agriculture, for image processing in agriculture, like strawberry like harvesting, or apple harvesting, or orange harvesting. Okay, so this is it. So for segmenting the coin, for segmenting the image, like you could use like C equal to the A is the input, A is the input, so I'm just multiplying the binary. Okay, so if you check now, so this I'm checking this variable segmentation. Okay, for segmentation, run the program. Okay, shows error integers. Okay, so the L is binary, so we have to convert that L to uint8. Okay, uint8 is unsigned integer 8. Both should be on the same data type. Okay, so I choose this one, right click, evaluate selection. It works. It works. Okay, so if you comment this line, you will get the entire segmentation part. Okay, so this is a simple example for segmentation. Still, I think L has been configured at some place. L, okay, clear, close all. Okay. Okay, only one coin has been segmented. Give me a minute. Let me check the program. If I configured it someplace. Okay, here. This is binarized. Okay. So you could use breakpoints to stop the execution of the program. Median filter like this. Like if you check for L BW label C. Okay, I'm sure. I will check the L now. Show of L. Okay. 8 of L. Okay. Yeah. Okay. I'll go for the code from the program. Let me check here. Sample 10. Okay, run the program. Okay, so this is the segmented coins. It works on this code. Like we have some problem on we have done some mistakes on the previous one. uint8. Okay, it should be on the median filter. Okay, it should be on the median filter. It's not on L actually. It should be on the median filter. See. So I click on evaluate selection. So check here. Okay, so now it's okay. So we have used from BW label, like it is for closed connected components. Okay, boundary label BW label is the command which is used to detect the closed connected components. So it will detect only one coin. So while doing segmentation, it segments only one coin. It has to be applied on the output of the median filter. Okay, I will repeat the code again. Like we have to read the image. Imread is the command which is used to read the image. Okay, imshow is used for display. This is binarization by thresholding. Okay, if you change this value, the results will vary. Since it is simple like this, there are algorithms to choose a best threshold. Okay, so just for to show you how threshold works, how thresholding works, and how segmentation works, and how to count the number of coins, I have used a simple image, but it never works for a complex image. You have to do a complex segmentation technique, or you have to do a complex thresholding technique. Okay, so b equal to a greater than 100. So 100 is the threshold. You have to apply median filter for removing the noise. And this is BW label is used for counting the coins. Okay, for count the coins. And like this, when you like this is for segmentation, I'm just multiplying that with a this median filter binary on the coins image, and just multiplying this one. So and get the segmented image. Okay, and get the segmented image. Like so it has to be on same data type. So I have used unsigned integer 8. Okay, so like if it is double, you have to use double. Both the data types should be in sub double when you multiply. Okay. So if this is clear, just type clear in the chat box. If this is clear, just type clear in the chat box. I'm waiting for a chat. If you want me to repeat, we'll close the session like we have one more histogram equalization. That is not a big thing. Like I will explain you on the presentation itself. Like so, is that clear? Thank you, Aniket Shah. Thank you. Uday Kiran, time up. Thank you. I will close. I will try to maintain the session time. Thank you. Washit Chauhan, clear. Thank you. Aishwarya Gadam, thank you. Aishwarya Nanda, thank you. Ashwini, thank you. So thank you. Like let us close the session. Like so we also have the internship, like 30 days internship. Like it's 500 plus GST. Like you will get the recorded video access for 90 days, and the PPT download and the source code download. You will get the source code download as well as the printed certificates. Like okay, of once the lockdown, we are currently in lockdown in Chennai. So once the lockdown gets over, we'll be sending the printed certificates from the certified by the Andhra Pradesh State Skill Development Corporation. And like we have nearly around 10 projects like on this curriculum, like the steganography and like lot of projects, segment deep learning kind of project, deep learning, transfer learning, machine learning. We have projects on that. Everything will be on. Seeing this video, you could also replicate this session. It is like the video will be available on YouTube for 3 days. You could go through the video and you could do the same thing on your code. And we are launching the forum tomorrow for the paid participants. Like you could also post it on the forum. Like the if you have any error, just post the forum. Like we have a team to support. Okay. And so these are all the projects which was included in the head, like image compression, segmentation, denoising, object recognition, and gesture recognition, augmented reality, steganography, cryptography. All these for 500 rupees. Like you could compare with this is also free for on YouTube. I will explain the code line by line. On seeing this YouTube, you could also replicate the code. If you want to watch it, watch this projects after 3 days, like if you want the access more than 3 days, the access currently will be for 90 days. We are giving 90 days access for this course, so you could practice on your own time. Okay, so definitely after completing this series 30 days, definitely like you could master the Matlab. On coming Saturday, like for the paid participants, we have the Q&A session at morning 10 o'clock. You will be receiving email probably today or tomorrow. You just register for that for webinar jam. So if you have any doubts, like you could ask me directly on webinar jam live. Okay. So thank you for your time. Thank you so much. I will take the Q&A and I will close the session. And sorry, I have delayed the session. Like I will go for Q&A. Okay. Thank you so much. Like Shoxy, thank you. Shoxy Keshari, thank you. Segmentation is used to remove the object from background. Biram Bhavan, like segmentation, like Biram Bhavan, like segmentation is used to remove the object from the background. Okay. Like Ashwin Purty, thank you. Nakul, slow voice. Okay, I'll try to improve. Johnson 123, thank you. Please share codes. Other like share codes will be available only on the portal. Like Amrita Banerjee, thank you. Aditya, thank you. Sanjay, thank you. Ashwil, thank you. Like thank you, Raghav, thank you. Okay. Thank you, Himanshu Jain, thank you. Amazing session, thank you so much. Dr. Akshay, thank you. Arya Jain, thank you. I will take 5 to 10 questions. Like if you have any doubt, like you could ask me. But what is threshold? See, threshold is the value like which the value above the threshold will be 1 and the value below the threshold will be 0. For example, if I give 100, it converts that to a binary. Okay, before the grayscale image you will be having 0 to 255. So the value above the 100 will be 1 and the value below 100 will be 0. So that is what threshold is about. Okay. Can you get the source code? Source code is available only on the portal, but you could replicate the same on seeing the YouTube video. It's there for every project. I assure you that For everything, you could going through the video on YouTube, you could create, but the thing is you have to complete within 3 days, else you have to invest 500 rupees. It's not a big amount. Like what you are going to invest is a value money. I assure you that value. And if you don't feel that is value to us, you just send an email. We will refund back to you. Okay, we'll refund back to you. Can you suggest any book for Matlab in mathematics? Just learn from Samyuk Gota. Like there are a lot of content available on the internet. You just follow this 30-day series daily. Definitely, like you will get a change. Samyuk Gota. Okay. And for boundary BW label, like Puneet Mittal is asking BW label. It's a boundary label. It is used to count the number of components, binary components, like the closed connected components. For example, if you have 10 or 5 binary components, binary will be zeros and ones. Okay. For example, if you have the segmented value, segmented that white color region, 5 regions, that will count. Boundary BW label, you could label those, and you could segment. You could also take, you could do a lot of things. Like you could find the area. For example, you do tumor detection. When you get a binary, like binary mask, you could get the size of the tumor and the area of the tumor by using the BW label combination of region props. Okay, you could get the area, centroid, bounding box, lot of things are there. We'll be covering it in the upcoming session. How to convert RGB to color? RGB to color. Sorry, I think Anikat Adwaryu. I think you were asking about how to convert grayscale to color, right? RGB, color is always RGB. Grayscale to color is not possible. Okay, grayscale is color. There is a command called label to RGB, but it doesn't work. Like you cannot convert the grayscale to color image. You could convert RGB to color image. That's okay. Histogram. Sir, explain histogram. See, histogram is nothing but like it's a probability of number of pixels. For example, you have 256 into 256 image, 256 into 256 image. You take a 256 into 256 image, it will have 65536 pixels. Okay, so histogram gives you the plot. The value will be, the range will be between 0 to 255. The count, how many, for example, how 100 if it, the 100 pixel, like if you take a pixel value of 100, how many pixels are 100 the value? So that count it will take. So it will give you as a plot on histograms. Okay, like probability of occurrence. 0 pixel, how many count is there? 1 pixel, how many count is there? The range will be 0 to 255. If you take a grayscale image, the range will be 0 to 255. It will give you the probability of occurrence. Histogram will give you the probability of occurrence. Like the x-axis is 0 to 255, and the y-axis is the count of the pixel. The count of the, like if you take 256 plus 256, it is 65536 values are there. If you take the matrix, it depends upon the size of the matrix. If you take more 1024 to 1024, then 1000, you multiply that with 1024 to 1024, that much pixels will be there. It gives you the probability of occurrence. What is the use of edge detection? Edge detection is used for feature extraction. Like a lot of applications are there for edge detection, for contour, for detecting contour, or for like it has a lot of features. For edge detection, has a lot of features. Is this certificate be used for? Can you? What is the use of edge detection? Shravant Sheth. Edge detection is for feature extraction. Like a lot of applications are there. Complement is just to like see some applications, like it depends upon the context of the application. Some applications you need a complement, IM complement. For example, in license plate recognition, in some cases we use to complement the image to get to use the BW commands, BW label commands. So it's just a mathematical operation. So what happens inside image processing is a pure mathematics. Okay, it's a pure mathematics. It's a matrix theory. And like the Fourier transform, Laplace, like you cannot use Fourier transform for image, but you could, the Weyl transformation, cosine transform, sine transform, Hadamard transform, all are a complex mathematics. So you convert, what we are dealing is a digital image processing. You get matrix, convert that to an array, whatever you want, or convert to transform. Okay, it's so complement, like you could use complement is it's a mathematical processing. So image addition, image subtraction, IM multiply, IM complement. These are all the mathematical, how to do mathematical operations on an image. Because like object recognition or segmentation, face recognition, everything is mathematics. Okay, you could derive as a mathematical model on it. You could derive as like you could mention the equations and you could write as like a sum. You will get the output. Okay, Milli Mageshwari, thank you so much. Used for image. Bonu Srinivas Kopulu, sir, this certificate be used for image as actually. Like always take the value. See, I'm not sure about the certificate, the validity of the certificate. Like. But you take the value is the key value is the knowledge. Okay, what we are sharing is what we work on the current, like for the past 16 years, and like when we work on the algorithms, we want to share you both the mindset as well as skill set, because the success requires both. Okay, so skill set alone is not enough. You have seen a lot of people who is good on knowledge and they're not successful because of their mindset. So we want to give you on this 30 days of both mindset and success, mindset and skill set. Okay, so that's a value, key value. Certificate is just a proof, like for attending, or just a compliment, like that's all. But the value, we assure you that you get a enormous value on this course. Nagur, thank you. Nagur Wali Shoik, thank you. See, if I am pronouncing your name wrong, thank you. Sorry for that. Sorry for that. I'll also put this attendance form on the description box. Give me a minute. Okay, I will put it later. I'll put this. I'll put it later. So, with this median filter, okay. I think the time is 9:45. With this, we close the session. Like, thank you so much for your time, and thank you so much for coming. Thank you so much for coming. See you in the next session. Until then, bye bye. Thank you. Stay home and stay safe. Okay. Thank you so much for coming.